Number 12, draw a graph for the description given. In the textbook, if we were looking and working pencil and paper, you would draw the graph. Are you really going to draw it right here? No, you're going to pick out the one that matches the description. The vertices are A, B, C, and D. The edges are AC, AD, BD, CD, and BB. BB, this means there is a loop. They've drawn the loop kind of small, but only one of the choices has a loop at B. Choice C. You can check the others. Okay, I have the loop. I'll put a little check mark. AC, AD, BD, and CD. There it is, the third choice. Number 14, this is the one I kind of was thinking of when I said some of the graphs just look terrible. Number 14. If you look at this first one here, let's read the question first. Explain why the two figures show equivalent graphs. Then draw a third equivalent graph. So as I look at the one on the right, the vertices are positioned kind of in a square. They're not connected in a square, but they're positioned like they'd be the corners of a square. And they're connected D to K, there's an edge D to G, there's an edge D to P. There's an edge from G to P. So this graph on the left should have the exact same connections. If you look at vertex D, this is just terrible. All those lines, edges, seem to be merging before you get to D. So you kind of have to just know that that's the way they're drawn and think, wait a minute, they don't merge. It just looks like they do. We have D to G. I got that one. I got that one right here. We have D to K. Got it. D to P. And there's one more edge, G to P. So they are equivalent. Pick the reason. They told me they were equivalent in the beginning. The vertices are connected in the same way. Select all that apply. The graphs have the same number of edges. The graphs have a number of edges that matches the number of vertices. That's not about equivalent. That's true, but that's not about. Part C is saying they both have 4 edges and 4 vertices. The number of edges matches the number of vertices. That's not equivalent. The graphs have the same number of vertices. I remember this problem from, I think, last semester, and I answered A, saying the graphs have the same number of edges. That doesn't by itself make them equivalent. It is true, but that doesn't make them equivalent. And the same for D, the graphs have the same number of vertices. That is true. They both have 4 vertices. That doesn't make them equivalent, but if I recall from last semester, the computer's expecting you to select all 3. Somebody double check that for us. I don't know if I printed out the answers. I don't think I did, but just kind of know that that's the way that one is. Let's pick our equivalent graph from below. Let's see, I have D to K, that's a single line. I'm thinking this is it. Got the little triangle, D to G, P to G, P to D, it's C.